the radius is what? 1 unit, right? So hence why they call it the unit circle. Okay, so notice that helps us out. If this is 0, 0, then this point right here is 1, 0, right? I would suggest you draw a unit circle. Okay, 1, 0. So, therefore then, I know this is 0, 1, negative 1, 0, 0, negative 1. Okay? Yesterday we also talked about how much is a whole circle. If this is 0 degrees, this is also 360 degrees, right? So if we cut a circle in half, how much is that? 180 degrees. Okay, 180 degrees. Well, if I cut 180 in half, what do I have? 90 degrees. Okay, any questions there? Well, therefore, every quarter, right, or a quarter of a circle is how much added? 90. So if I went 0 plus 90, 90, 90 plus 90 is 180, 180 plus 90 is 270. And then 270 plus 90 is 660. Everybody with me there? You go in there and complete that. Okay, well, we also talked about this as being 0 radians and this as being 2 pi radians, correct? We cut it in half. Well, we know this guy is pi. We cut pi in half, that is pi half. So 90 degrees is going on every 90 degrees of pi half, right? So 0 plus pi half is pi half. Pi half plus pi half is 2 pi half, which is pi. 2 pi half plus pi half is 3 pi half. 3 pi half is 3 pi half. 3 pi half plus pi half is 4 pi half, which is 2 pi. Anybody have a question on where I'm getting that from? Okay. Now, circle, right? I used to have everybody do this on a plate back in the day. Okay, unit circle, fold it over. Okay, that represents half of a circle, so therefore we just cut it in half. That was where the 180 or the pi came in, right? Cut that in half, that's where the 90 comes in. It's the quarter shape, right? 90 degrees, okay? Or pi half, okay? If I cut 90 in half, where are we at? 45, and that just means also we just cut pi halves in half, which is half of pi half, or pi fourths. So we just do everything with pi fourths. Pi fourths is 45 degrees. Remember, as well as we talked about yesterday, we talked about reference angles, correct? Notice, this angle from here to here is 45 degrees. That is 45 degrees. That is 45 degrees. That is 45 degrees. Correct? So, if you recall, last year, how did we get to the coordinate of those? Well, I'm going to show you that in 1 second. Okay, it is a special sign. Well, we could also count our 45 degrees. 0 plus 45 is 45. 45 plus 45 is 90 and so forth. Why do that with radians? 0 plus pi fourths is pi fourths. Pi fourths plus pi fourths is pi half, right? That's 2 pi fourths. Then I got pi fourths plus, 2 pi fourths plus pi fourths. This guy right here is 3 pi fourths. And notice we're cutting back 45 from 180, which is 135. Everybody understand that spot? Okay. 3 pi fourths plus pi fourths is 4 pi fourths. 4 pi fourths plus pi fourths is 5 pi fourths. Then go put in 180 plus 45, so that is 3.35. Everybody there? Okay. 5 pi fourths plus pi fourths is 6 pi fourths, which is 3 pi half. And then 6 pi fourths plus pi fourths is 7 pi fourths. And notice this would be the same thing as 360 cut back to that 45. the unit circle. What was our radius? 1. Wasn't a circle touching this point right here? So from 0, 0 to that point, what's our distance here? 1. What does that equal to in our special triangle? The x raised 2. If I solve for x, I will know what these two sides are, won't I? Correct? So x is 1 over root 2. You guys know why this is not acceptable anymore? Or it should be now, but why isn't it? But why? Because you've been told that, but why? Anybody know why we're putting my square roots in our denominator? Let's divide. Okay, do you guys know what square root of 2 is? No, we don't. Unless we have a machine, a lot of us would. Okay? Instead of a machine that told you what square root of 2 is, they had charts. In every math book, they have charts to tell you when it's square. Okay? How can you divide a number by a number that goes on forever? Because the square root is a irrational number that goes on forever. How can you do that? You can't divide something that goes on forever, right? It's kind of hard. You can't have stopping. Does that make sense what I'm trying to say by that? So they rationalized it. So they went root 2, right? They said, okay, well now that's the square root of 2 divided by 2. Can I take a number that goes on forever and divide it by 2? Sure, you just got to have a stopping point for you finally, right? And you can get an estimate, correct? That is why they rationalized their denominators so that they know how to divide them. Right? But now we have a machine that has a logarithm, not logarithm, but an algorithm that can do that for us. So really, isn't that a big thing? Or will you ever see any math test that looks like that? Never. So once again, that's why we still continue to go on. Okay? So therefore, if this side is 1, this side is root 2 over 2. And this side is root 2 over 2 as well. Can somebody tell me, if this point is 0, 0, what is this coordinate right here? How far did we go over? Root 2 over 2. How much did we go up? Does that make sense where that came from? Now I can come over here and I can fill in, this would be root 2 over 2, root 2 over 2. That is where that coordinate came from.
You are doing so well over there.
You working tonight? How about on the other one? 11 is the next one. Huh? On a scale of 1 to 10 in my favor, how many would you give that? Yes. Yeah. Alright, so what's this coordinate? Huh? This is negative root 2 over 2. Gavin, explain why it's negative. And this is 0, 0, so we're going left for our x's, up for our y's, right? Make sense? Haley, you darkened your hair a week ago. I knew that, but I never said anything. I apologize. Okay, this guy is root 2 over 2, root 2 over 2. Who gets the negative here? Both of them. Okay, because you're over and down, right? Does that make sense? And then this guy over here, root 2 over 2, comma, negative root 2 over 2, because you're over positive but down negative, right? Does everybody make sense of that? Okay. I'm trying to go through this as best I can. Oh, we got 11. Okay, now we got 30 degrees, right? Because notice once again I'm coming back here. This is 90. This was our 90. So instead of cutting in half, I put it into thirds. Okay, looks like such. Blah, blah, blah. And you get the, basically the reason why I do this is it shows you the lines in the unit circle. That's where it comes from. So notice this was 90 and I cut it in thirds. How do I know what that is in radians then? Well, in degrees, really quick, I guess I could go over this. This is degrees. This would be 90 cut in thirds. That'd be 30 degrees, right? Same reference angle again.
know the degree, you can do the degree piece, cause you know like the degree, but when it comes down to radians,
Well, you could convert everything as well. That takes a lot of time. I don't know if she's
we
fine.
didn't know how to transfer it though.
Really?
We didn't know how to convert it, so.
That makes sense why you guys have bad feelings. But if you understand it, cause like this is 6 pi 6 plus another pi 6, which is 7 pi 6. This is 2 pi is 12 pi 6, but you're cutting back pi 6, so it's just 11 pi 6. Okay, is everybody there with me? Well, now I'm going to hurry and do 60 before we get to our quadrants here real quick. Notice, this is 30 plus 30, 60. And so therefore pi 6 plus pi 6 is 2 pi 6, which is pi thirds. Notice this is 60, and if I cut back 60, that's 120, which is you just double it, so that's 2 pi thirds. Okay? Well, this is 60, if I add 60 to 180, that's 240, and isn't 240 just doubling 120, so that's 4 pi thirds. Okay? This guy right here is 300, because I'm going 360 cut back 60. Well, 360, they're all about 6 pi thirds, right? So we subtract that, pi thirds, and this is 5 pi thirds. Or, ladies and gentlemen, just M. 60 plus pi thirds plus pi thirds is 2 pi thirds. Plus 60 is 180, which is 3 pi thirds. Plus 180 is 4 pi thirds. Plus 180 is, plus 60 is 300, which is 5 pi thirds. Plus 60 is 360, which is 6 pi thirds, which is... Now the memorization doesn't hurt, but it is nice to know what it is, right? Where it's coming from. Okay, now we can get the coordinate by doing also, we have this triangle of our special triangle, where this guy is 30, this guy is 60, and this guy is 90. So on our special triangle, let me explain the ratios that we have here. The reason where this came from, by the way, is an equilateral triangle. 60, oops, sorry. If it's equilateral, that means all these angles are 60, right? What they did, and notice this, we'll call this guy X, X, and X. Okay, because all the sides would be the same, correct? Well, what they did to make this 30, 60, 90 is they cut this angle in half, this angle bisects, which made this perpendicular. So there's our 30, 60, 90 triangle. So what did this do to this side right here? It also cut it in half. So this guy was X, this guy right here, this is the side opposite of 30, it means that shape is 1/2 X, right? Now where does this guy come in? Well, that guy comes in. I could also switch this, by the way, if I doubled that, this guy could just be X squared. What? So that's X squared plus B squared equals C squared, which is 4X squared. Subtract it over. B squared equals 3X squared. So B equals X squared over 3. That's where this comes in. Right? But what is this once again on the unit circle? 1. So therefore 2x equals 1. What does x equal? 1/2, and that's the side opposite of the 30, right? So therefore this side is 1/2 root 3, or root 3 over 2. Okay, so what is the coordinate up there? Root 3 over 2, comma, 1/2. Does everybody understand that? So it would be at the 30, right? Because I'm over root 3 over 2 up 1/2. And that picture looks like I'm over root 3 over 2 up 1/2. That looks about halfway over. Hey! Well, you see those lovely boxes over there? I didn't make you put them work because you're getting a little tired. Yeah, well you put those underneath, like the ones that are already out underneath the things here. And then the boxes that are in there underneath the thing. Hey! root 3 over 2? Because once again, remember our x value became the half. So that's our x value, and we'll put x times root 3. So root 3 times 1/2 is root 3 over 2. So therefore, when I start filling in, this is root 3 over 2/2. I know this isn't as pretty, but you get the idea. The main thing is getting the idea, right? And then this guy is root 3 over 2 comma -1/2 because he's over positive, down negative, right? This one up here is negative root 3 over 2 comma 1/2. And then this guy's negative root 3 over 2 comma -1/2. Everybody there? Okay, now with red, it's vice versa. Because notice if I did my triangles differently, like this way, this is 60, this is 30, this is 1. Remember the side opposite of 30 is 1/2. And then this guy would be root 3 over 2 because it's the same triangle that we already just proved, right? We just rotate it, correct? Okay? So, therefore this point became 1/2 comma root 3 over 2, -1/2 comma root 3 over 2, -1/2 comma negative root 3 over 2, 1/2 comma negative root 3 over 2. Now, let me show you an easy way to memorize this if you would like it. Okay guys, do you know how to count? You can use unit circles. Notice, check this out. 1 is the same thing as 2 over 2, right? Or 2 is the same thing as square root of 4 over 2, correct? Square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. The square root of 4 is 2, and 2 divided by 2 is 1. Right? It's all about just counting. And notice if you memorize this quadrant right here, you have the whole rest of it, correct? By using your references. Only one quadrant you got to memorize. Then you got to justify where the angles are, but besides that, if you know the coordinates, you can then fill them here with that. No problem. Okay, how I counted or how I did what?
No, no,
It's just a little pattern, because 1 is the same thing right here as 2 over 2, which is the same thing as square root of 4 over 2, right? So that's square root of 4, square root of 3, square root of 2. This is 1 square root of 1. Square root of 1 is 0, square root of 0 is 4. Yeah. Okay, say it louder, I'm sorry. Okay, but just understand, isn't 1 the same thing as 2 over 2? And isn't 2 over 2 square root of 4 over 2? I just made it so that you can see the pattern. Square root of 4, square root of 3, square root of 2, square root of 1, square root of 0, because they're all over 2. Notice here I started with 0. If you know that this point's 1, 0, then you don't need to count it. Because this is square root of 0, square root of 1, 0, square root of 2, square root of 3, square root of 4. Okay, which one of that last year? I forget what that was. Huh? Not sure. I'm just trying to show you how these are all equal. So why it looks that way. But once again, just memorize the coordinates. Basically, if you use this coordinate, it's the same coordinate over and over, right? And you just then have to use the reference angle to tell you where they correlate with. See those boxes? Yes, the boxes. Oh, you good? The boxes. Sorry about that. Good. Good man. Love you. Ladies and gentlemen, that is the unit circle. Okay? That is, it is used. It is expected to be memorized. So when I say this cosine of pi 6, okay, I want you to say just as this, cosine pi 6 is root 3 over 2. That's what I want. Okay? You cannot do that. You need to memorize it more than just this test. The faster you do it, it's better because we're going to start using all these a little bit later. So, in our notes, why is the unit circle important? Or why do we use it? Well, because we have our 6 trig functions. Does anybody remember the 6 trig functions? Sine is 1. Okay. Cosine is 1. And then times secant by cosine, excuse me, secant by cosine, guess what you get? You get 1. Because they're reciprocal. If you multiply them, then those reciprocals cancel out. They're like 3 and 1/3. If I multiply those together, I would get 1 with it. Okay? And then we have tangent, which is, its buddy is cotangent, which is kind of a little different. Okay? Now, to be honest with you, some guys get confused. That they want to say cosecant goes with cosine because of the secant part. So my little saying is, the toes don't go. Okay? Just think about the toes don't go together. Except for the cotangent. But they don't have toes. So the toes don't go together. Okay? Does that make sense? So cosecant goes with sine. Secant, that is not the same button as the button. Not the arc sine. That's why I don't like that lovely cosecant. C-O-secant. Co-secant. Not a double C-O. I want to scribble that so bad. Sharon the other day at wrestling, I was writing notes, and I was like national anthem notes, national anthem. She loves that. Introduction. Intro. Perfect. But I am. It starts with an I. What starts with an I? Oh, an introduction. Abraham Lincoln. There's only one key person who's going to pay that in the history of 1865.
Is that a
College. Okay, now you'll recall, hopefully, guys, SOHCAHTOA, or some old hippie, Kate hippie, tripping on apples. Not acid. Yeah, so I decided not to do that. So I decided to go tripping on apples, because those hippies just trip on apples all the time. Or, SOHCAHTOA. So if we recall, yes, that was on before that. So SOHCAHTOA, once again, remember, is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. You guys remember those from last year? Okay. Well, remember, if this is the reciprocal, therefore this is hypotenuse over opposite. This is hypotenuse over adjacent. This guy is adjacent over the opposite. Well, I'd like to show you something as well. Sorry, guys, I'll hurry and let you catch up. Would you get your such and such shirt? Or your father get your such and such shirt? Again. We got them? Okay, look at these special triangles, because, notice, ladies and gentlemen, if I said, what is the sine of 30? Sine of 30, opposite 1/2 over 1, because that my unit circle has a radius of 1, my hypotenuse is always going to be what? 1, right? So therefore sine, notice that this, look over here, sine of 30, where's 1/2? The y value. So you might want to write that in your notes as well. Sine is just your y value over your radius, but in our case, on the unit circle, the radius is what? 1. Okay? Cosine is the x value, right? And then tangent is y over x, by the way. So what would cosecant be? Your radius over your y value, your r radius over your x value, or your x over y. Okay, those are important to know. So, hopefully everybody has their, I think I got 3 minutes. Okay? in the unit circle, this is the type of question I could ask you. Please tell me the sine of 210 degrees. So you're going to go to 210, right? And you look over there, and you look at the coordinate, and you say to yourself, okay, sine is the y value, and so therefore, as Cassie's telling me, negative a half. Correct? Does that make sense? Now if I ask you what is the tangent of pi thirds? Let's go actually 2 pi thirds, please. So tangent is the y value over the x value, correct? So what is the y value? Root 3 over 2 over negative a half. Okay? So whenever we have a fraction over a fraction, we like to go ahead and times by the bottom guy's reciprocal, because therefore those guys would cancel out. But I just can't do it to the bottom, I gotta do it to the top as well, correct? Negative 2 over 1. Notice those guys cancel, so therefore that is negative root 3. Can somebody tell me what the tangent of 3 pi halves would be? It'd be undefined, because notice what is the y value at 3 pi halves? Negative 1, what is the x value? 0. I can't do that, can I? Okay? Alright, I don't have time to get to one of our other theorems. We'll have to discuss that next time, okay? Huh? Not off of this one. They were 2 minutes behind, right? So do I have time or no? By the way, you're on 4-2. How about we'll do this? I'll give you your assignment. I'll go and tell the bell. 4-2, I believe you're doing 1 through. Anybody have their book open for that unit yet? Can't remember from yesterday. I'm sorry. 4-2, 4-2. 1 through 51 odds. That's it. Yep. Actually, was it 7? Might have been 7.
I think it is.
Oh, is it?
Yeah.
Oh, no, but there's 1. Okay, the one thing I didn't get to, there's 2 things actually I remember now. What if I gave you a point right down here, and I said this point right here is negative 5, negative 12. And I ask you to please tell me all 6 trig functions. So first off, you're going to draw the triangle, okay? What does this side become? No, because this would be negative 5, 12 would not be on it. This would be negative 5, because that's your x value, right? What would this be? Negative 12. If you did Pythagorean theorem, this guy comes out to be 13. This is always because this is just going to always be positive, just to let you know. What if I ask you for your 6 trig functions? I'm going to be quick and I'm sorry. Sine of that angle, I don't know what that angle is, so I'm going to put theta, is, if you recall, it is your y value over your radius. Or, if you stood here, opposite over hypotenuse, right? So therefore, what is cosecant? Negative 13 over 12. Did you see that? If I said, what is your tangent of theta? Remember, it's the y, which is negative 12 over negative 5, which is 12 fifths. Y over x, right? Okay. So if I ask you for the cotangent, it is x over y, so that would be 5 over x. Okay. Get the idea of what I'm going for there. Okay. There's one more theorem. Looks like I'm okay. There's one more theorem, and it says sine of negative t negative 30. That's the same thing as just doing the negative of tangent of 30. So you just find what the tangent of 30 is and then negate it. Does that make sense? Cosine absorbs it. And I can explain why picture-wise next time if we miss. Thanks, guys.